Corey. What am I trying to move over here? There. Okay.
Miss,
Share.
what was that video for?
That's for later on.
For the what?
That's later on. Can y'all see my screen at home?
I can see it.
Page 11.
Yes,
Yes?
I can see it.
Let me see if I can write. If it works. It works. I know y'all can see it. Shake your head if you can see my writing at home. Oh, here we go. Y'all see the red writing on there?
Yes.
Perfect. All right. 9A. For a fourth grade field trip, 252 students rode in 6 buses to a nature preserve. Each seat on the bus held 2 students. If each bus carried the same number of students, which equation can be used to find the number of students on each bus? There's some keywords in there. There's some keywords on there. There's some keywords on there. Tell me what some of these keywords are.
I think
Each. So what does that mean we're going to be using?
each bus.
Get. Yeah, we're going to be using get. We are going to be using get because we know each on each bus. Okay, okay. So get. All right. Chloe says get. So we're looking for the number of students on each bus. So do we know our E? It's missing. So we already know we're going to be doing what? Dividing something. Okay, let's figure out what we're dividing. What's our total number of students on the bus? On the 6 buses?
A total of seat.
252. And then how many buses did they go on? 6. So we have our setup already. We already said that we're dividing because we don't know our E. We're looking for our E.
Yeah, we don't know our each.
So it would be 252 divided by 6.
What answer is E?
What?
Answer is E.
B or D? Yes. AJ, where are your glasses at? You forgot them?
Wait, Mr. Hernandez, that's a 5, right?
Huh?
That's a 5, right? Because it kind of looks like an S.
Yes, it's a 5. Make sure you're writing this down. I might have to make it bigger. Are we ready for 9B? There we go. All right, home. We are ready for 9B.
I'm ready. I'm ready.
Let me make y'all bigger because I can't see y'all. I'm gonna have to get glasses so I can see y'all. I can just put y'all like full screen probably. Or not. Whatever. Or not. Okay, 90. Each row at the Bronx Bronx Stadium has 42 seats. Each section of seats has 25 rows. Which equation can be used to find the number of seats in each section? I just had one paper. Oh, right here. Let's see. So which equation can be used to find the number of seats in each section? So what are we going to be using? Somebody. Yeah, we're going to be using get. Let me make this a little thicker. So get. There we go. That's better. Right? That's better. That's better. That's better. So we have two numbers there. We have each row at Bronx Stadium has 42 and then each section. So how many, I guess it wouldn't matter either way. How many seats are in each row, I guess? I guess you can use 25. How many groups do we have, or how many rows, I guess? That would have been another day. 40, what? 42, yeah. So what are we gonna do here? What are we gonna do? Huh? At home, what are we gonna do?
Multiply.
Multiply, right? 42 times 0.5. 42, oops, is that it? Yes. 42 times 25, right? Equals 9. Oh, wasn't too bad. What was it? What was it? Next. It's gonna be kind of hard. We have it at home? You see how we got our answer, or we're lost? Let me know. Remember, you see each and there, a lot of times you're going to be using what, Chloe? Yes. Also on skills. Oops, I put the wrong pages in here. Okay, moving on. Skills, page 63. Ooh, my favorite. Quickly. And that mask needs to be on. I don't know why it's not on. 63. 63. Ooh, my favorite type of math. Hurry. This is really important. Really important. 63. Some of y'all may have heard of like trailing zeros or carrying zeros. Have any of y'all heard of like trailing zeros or carrying zeros?
What page is this again?
63. There's a lot of skill. 63. Trailing or carrying zeros?
63 or 53?
63. 63. The law of trailing zeros. See, I've never heard of them. Carrying zero. So when you're multiplying and you've got zeros, it's called carrying or trailing zero. So your two zeros would move over here, both of them with you. Okay? So just like that. And then that erases. You're left multiplying 6 times 2, and it's what? 12. And you have your answer. That's trailing or carrying zeros. Huh? So on B, how many zeros are going to move to the right with us? 2. So our 2 zeros, 1, and then your other 0. And then you're going to multiply 9 times 6, or 9 times 4, sorry, 9 times 4. Okay, y'all at home.
Yes.
How many zeros are going to move over on C with us? The zeros move all to the right with us. Every zero in your number. So how many are going to move to the right?
2.
Yeah. Watch. Once y'all get a hang of this, you're going to be like, oh, this is easy. And then you're left multiplying 3 times 5. And what do you get? At home, what do you get? 3 times 5.
15.
15.
Y'all see how this is super, super easy when you got your 100, when you're multiplying times 100, 1,000, 10,000, 100,000. It's the same thing. D, here in class, how many zeros are going to move over with it? 2. So then we got 1, 2. My 2 zeros, they come along for the ride. And we're left multiplying 2 times 2. What do we get? 4. They're goose eggs, yes. So, at home on E, how many zeros are going to move over with us?
2.
2. What's the easiest thing you learned in 4th grade? What's 6 times 7 at home? At home. What is it?
Hold on.
Oh man, we're not awake yet, are we?
42.
42.
Bingo, yes.
42, right?
Yep, 42. Ooh, F. F has an extra 0. What do you think we do? Come on, Michael. We move all the zeros. We move our other 0 over. Are y'all understanding what I'm doing here, right? I'm pouring my zeros or trailing zeros, and then you're left to multiply 6 times 4. What is that? 6 times 4. Somebody.
6.
24.
4. So we got 24,000, right? Whoops. Whole part of us going okay. Oh, 8,000 times 1. Yep. Your 3 zeros. And you got 8 times 1 is what? 8. Isn't that hard, is it? On H, how many zeros am I moving over? 3.
3.
So 1, 2, 3. And eventually you don't have to put your little lines like I'm putting if you don't want to. You have or you haven't? But what you need to make sure you're doing though is that you know you're putting 3 over there, okay? Put your lines. What's 4 times 5? 20. And you put that 20 there. Don't think you don't put it. On I, how many zeros are moving over? So your basic math is very similar to this. So I wanted to go over this first. And then 3 times 7 is 21. So you got 21,000. Jacob, are you getting this? Let me make sure. Well, you're sitting back here. Chloe's back. You're back if you can tell me if you're doing or not doing, okay? So. Back. Maybe then you're gonna do your work, right? But you are doing it. Jay, how many zeros? Come on, catch up with us. We went over all of this.
3.
3.
Yes.
Bingo, they come along with the ride. 8 times 9.
72.
72. 63. Nope, that's 9 times 9. 63. Okay, y'all I'll do 1 through 10 and then I'll go back down and do the bottom, okay? 1 through 10, I'm gonna want to see it. 1 through 10. I'll do 1 through 10. We'll do the bottom. We'll come back and do the bottom. Like round two. Ready, 1 through 10.
Miss Fernandez,
Yes.
can you like go down to the, wait, what's the page again?
63.
Okay, because my things have
61. 63. Come on. If you don't know the page, you can always, well, I don't know that you can see it. Those 9.
I couldn't see it because you have the
Oh, yeah. So how many zeros are going to move over there?
2.
Yes. How much easier it is when you do your work, Jacob? Trailing or carrying zeros? Adrian. I'll go with Adrian. Alright, how many zeros did you carry? 2 times 12 is what? Yeah, so you have 2 zeros and you have 10. Come on, you missed it. So you carry those 2 zeros to the right on number 1, like I did. So move 2 zeros over on number 1. Yes. Yeah, put 2 zeros. Then you're left multiplying 6 times 2. What is that? Where's your chart at? They gave you. Come on, that should be the first thing you pull out for math. Anybody need help online or you're good? Where's your big chart at? Ah, I got it. You don't want to use it? Use it. Okay, don't use it if you want to use it like that. 6 times 2, 12. Okay, so now how many zeros are going to move over on 2? The same thing you did. 2. And you're left to multiply 5 times 2. There you go. How many zeros are going to move over on that one? 2. Yep. And you're left to multiply 9 times 3. Right? 9 times 3. Yeah. How many zeros, Michael? Thanks, he gave me some markers. That's 17. At home, you all have any questions, comments, or concerns?
I just need 2 more to do.
Okay. By 9. We should get to- Hey, we're not adding that. 7 times 5. Good. You want one of those cards? Yeah. You finished calling? Okay.
Mr. Hernandez,
32.
Mr. Hernandez,
Yes.
may I go to the restroom?
Yes. This is easy. Yeah, this is probably one of the easier things to learn in 4th grade. I'm on like one. You can do it. The measurement wasn't that converting wasn't bad. When we start doing like capacity, it gets a little bit harder. Then we start dividing more. Like when we learn that, I think in this like it gets a little harder. Give you until about 9, and then we're moving on. Or we're gonna go over it. And we're gonna do the bottom part. If you want to, you can go do your basic facts 9 because it's very similar to this. Yeah, basic facts 9 is very similar to what we're doing. Number 9.
What basic facts?
Basic facts 30, it's page 37. So you just carry what? How many zeros? Oh, weird. How many do you have? Or 8? How many zeros do you have on 10? 1. Put 1 and multiply 26 times 1 and it's what? Anything times 1, you get, yeah. So, okay. Very simple. Nine times 7. Look at you, you're working, you're earning your break today. No one here earning your break. It must be because y'all just had a break over the weekend. Adrian, you want one of these little charts? Put on the front of your binder? Tell me how you're earning your break this time around. Oh, surprising. Must be because we had the weekend off. Yes. You got 2 minutes. Stay ready. You need to keep that. Help or you got it? How many zeros are going to move over on number 4? I think we need our glasses.
Miss Hernandez.
Yep.
After we're done with this, what page is it?
Just hold on right there because we're gonna go over these.
Okay.
A minute. Just giving them a minute. All right, let's go over these. Number one, at home. Who can help me with number one from home? What did you get? Wakey. At home, what did you get?
I got 1,200.
1,200. Somebody here in class, what did you get for two? What did you get for number two? 2. 0, 2 zeros, and then 10, right? So 1,000.
2,700 for 3.
Yeah, so 2,700 for 3.
And then for 4, is it 300?
200. What about for 5?
3,500.
2 zeros and 35.
6 for 6, 63.
63,000. Yep.
And then for 7 is 16,000.
Hold on, Chloe. So, and then 8, you move 3 zeros, and then 8 times 5 is what?
40.
40. Number 9.
32,000
32,000. Good job. I like how you were saying the numbers.
and 54,000.
54,000.
4,000. Yep. Everybody's got this down.
Help.
Finish. My pants are all empty. Oh, it's his shirt. That's why. Shirt making it all empty. Sorry, my pants are all empty. It's bothering me. Bothering me. The bottom part. Let's go back to what is it? 8? No, K. K. Ah. K. Ooh, now we're gonna be rounding. Oh, rounding's back. Rounding's back. Ah, what am I doing? Rounding's back. So, on K, we're gonna go back and do the bottom now. K. Round 489 to the nearest 100, multiply that number by 9. So we got to round first. So 489 to the nearest 100. Okay. So the 8's going to tell me, are we going to round up or are we going to round down? We're going to round up. So that becomes what number now?
490.
Nope. We're rounding to 4. Huh? 400. Rounding to the 100th place. Remember, everything behind the 5 becomes a what? Everything behind the 5.
0.
No, whoever that was. Natalie. Now we
Natalie.
5 times 9. What do we get? What do we get?
What is that?
And then 4 or 5 times 9 is what?
45.
Try again. 45. You're close, Adrian. Times 9. Did you? Oh, sorry, I think you said 5,000. Okay. On L, round to the nearest thousands place. So 7, 4, 3, 6. 4 is going to tell me if we're going up or we're going to stay the same.
Stay the same.
We're going to stay the same. Why?
Because it's 104.
Yeah, it's lower than 4. So the 7 stays, and then what do we put behind the 7? A bunch of what? 0. 1, 2, 3. Now we multiply times 8. What's 8 times 7? 56 with 3 zeros, right? 56.
56.
Oh, bingo! Goodness, this is easy, isn't it?
Yep.
This is easy. 11. Round 932 to the nearest 100.
Wait,
And then multiply by
that is zero.
Yes, this is 0. Yes. So 932. Yeah. 3. Are we gonna stay the same or are we gonna round up?
Round up.
Stay the same. So we say a 9, and then what do we put behind the 9?
A zero.
2 zeros. So 2. Because we got 2 places there. 1, 2. So times 9. What do we get? 900 times 9.
1 times 9. 2 zeros.
2 zeros up.
81.
And then, not 81,000, 8,100. 8,100. Around 5,682 to the nearest 1,000. 5, 6, 8, 2. 6. Are we gonna round up or are we gonna stay the same?
Round up.
At home, are we rounding up or are we gonna stay the same? Somebody at home. 5 or more, raise the score.
Rounding up. Well, it's
Rounding up.
exactly at 5.
5 becomes a what?
Okay. The
6.
5 so
And then what goes behind the 6? Not 2. 3 zeros. Go ahead and change. Times 3. What is our answer? How many zeros come up top with us? Come for the ride. 3. Those zeros must be nice to be a 0. And then 3 times 6 is what? 18. Easy breezy, beautiful. Cover girl. That was easy, wasn't it? That was pretty simple. Agree? Yeah, I agree. That was simple.
yes.
Good, because we're gonna be doing it again tomorrow. Oh, yeah. Okay. You got it? Or not yet, Adrian? Got it? All right. Before we go anymore, you can close your math binder for right now and get your math journal out. We're going to be taking some notes. We're going to be taking some notes. This week in math, we are learning about no 2D shapes. Get your journals out.
Like zeros.
Yes. Yes. It's flat shaped. So like a trapezoid. Mostly we're going to be talking a lot about quadrilaterals, which if you look on the board, y'all have the advantage. You see them over here, what quadrilaterals are. They don't have four quadrilaterals. Yes. Antonio, can you go check on Jacob? I'm sure he's okay. So we're gonna be learning about 2D shapes, geometry. We're gonna be writing in our journal. We're gonna be taking notes. So 2D shapes. Let me share this with you. What's 2D shapes? Math! We're in math. We're in math. Hold on, guys. I was gonna look for a video just to introduce. So, where's my thing? So, yeah. Oh, and we have to remember not only that with 2D shapes, there's a lot this week because it's going over 2D shapes, primarily quadrilaterals. Does anybody know what a quadrilateral is? Or how many sides a quadrilateral has? Nope.
6.
Too many. Quad. Who said it?
4.
4. Quad means 4. So a quadrilateral has 4 sides. So for example, what's an example of a shape of a quadrilateral side? What shape?
Square.
Y'all have an advantage since y'all can see my anchor chart. They can't. A square would be one, right? What's another example of a quadrilateral that has 4 sides? Okay. A rectangle. What's another one maybe?
Well, like it's
A rhombus. Yes, the diamond rhombus.
yeah, rhombus.
And then there's one more. It's the parallelogram, which I'm not sure if you are too familiar with, but
Oh, I know the
we're going
parallelogram.
to be going over a lot. Well, a trapezoid too is a quadrilateral. A diamond? Is it? It's probably like crooked or something. I don't know. Kites. But yeah. So let me go over. Let me move this over there. Well,
Listen, I just can't see your screen.
I'm not really sharing anything right now. I will share something, but
Okay.
I guess I can go over and share something. And then also symmetry. Do you know what symmetry means? Quickly. Symmetry. Do you know what symmetry means? Going over a lot of terms this week. Symmetry.
Like a butterfly?
Not like, but what do you do with the butterfly?
Like is symmetry like something that like is symmetry like
I think I know, like when you fold it in half, is that what you're trying to tell me?
well yeah, like something like
Describe what you mean by the butterfly. Like if you fold a butterfly in half, it looks the same. Is that what you're trying to tell me? I'll pay
well,
attention. There's a lot
kind of like the wings, if they're the same, they have the same patterns or something.
So yeah, symmetry. Like if you fold something in half, for example,
They look exactly the same.
they look exactly the same. Yeah. So if I fold my paper in half and then I open it up, it's gonna look the same, right? So it has a line of symmetry down this way. Yeah. Or if you fold it the other way, it's gonna have another line of symmetry because it looks the same, right? If I open it up, it's gonna look the same. Yes, like the examples, yeah. So like if you have a heart too, like I have a heart, everybody make a heart with their hands. Make a heart with your hands. If you were to take it apart and put them together like this, they're gonna look the same, aren't they on both sides for the most part?
Yes.
So it has like a line of symmetry. A heart does. And there's certain letters that have lines of symmetry, and we'll go over more of that. There's a lot. But let me find the video I was gonna try to find. Hold on.
Okay.
Hold on. I can find a video.
Yeah. I'm thinking. Wait, hold on. Yeah. Mr. Hernandez,
Yes.
what time is lunch?
11, probably around 11:40 to 12:25, Natalie.
Okay.
No, I think it was Natalie. I get y'all confused all the time. I know. Okay. We're gonna watch a quick video, then we'll take some notes. Hold on.
This video is
I
going
know
to look
y'all
at the
cannot see it. Hold
attributes
on.
of some different two-dimensional figures.
Okay. I know y'all cannot see it. I'm not sharing it yet. I'll pay attention. We're gonna be looking at 2D shapes. And AJ mentioned it earlier. He said, "Isn't 2D shapes like flat?" Yes, they're flat. So like
Yeah, like a sphere is a circle, but in a 3D shape, and a circle is a 2D shape because like you're writing it on paper. That's not gonna be like a 3D.
a sphere would be a 3D shape. So like this would be, right here I have a globe. This would be a 3D shape, but the circle would be a 2D shape.
Like this circle.
Yes. Can y'all see the video over here? It says
Yeah.
2 dimensional features. Okay.
So when we talk about attributes, it's ways that we can describe figures. So we're going to start by looking at some quadrilaterals.
Yes.
Quadrilaterals are polygons with 4 sides and 4 vertices. So a vertex is the angle or where 2 of the sides meet.
It's like, what is going on?
You can also think about it as the corners. And the sides are the edges.
So, like we just mentioned, a quadrilateral is a polygon with 4 sides. So, like we said, a rectangle, a rhombus, a square, and hey, we're not drawing right now. Y'all need to pay attention. There's a lot of stuff on your test this week. It's everything on that board is going to be covered in your test, huh? Yes. They've got different names. Yes, and then the vertex or the corner. Remember, there's a lot on this test that we have to know. So pay attention. I was trying to do something. Oh, change my volume.
Of the figure.
Friday, but like there's a lot you
So a quadrilateral has 4 sides and 4 vertices. That also means that it has 4 angles. So we're going to look at the names of some different quadrilaterals and then whether or not they have parallel sides, sides of equal length, or right angles. So the first one is a trapezoid. And when we look at this trapezoid, we can see that the top line and the bottom line are parallel, but the right and the left are not.
So it's telling us that these 2 yellow lines are parallel. That's another thing you have to remember. What does parallel mean? They're not touching, right? They're parallel. They're not touching. That's another thing you're gonna have to know for this week. They can be like that. Yeah, they can be like this. They can be like this. They can be like this. As long as they never touch, right? So let's see.
Are you gonna
We're
write
to
this down?
continue
No, we're not gonna write this down today. Maybe we will tomorrow. I'm gonna write something else down. But
these lines, they're eventually going to intersect. So a trapezoid has 1 pair of parallel sides.
or I might type.
In this picture, the left and the right are equal length. So we can say that it has 1 pair of sides that are of equal length. But it doesn't always have a pair of sides of equal length. Just depends on what the trapezoid looks like. And a trapezoid has 0 right angles.
Beans and cheese. So see, this is what I mean by knowing a lot on your test this week. We have to know parallel lines. We have to know what a quadrilateral is. We also have to know what type of angles we're back. That's why our angles are back out. A right angle is how many degrees? Who remembers? Anybody? Somebody said it. 90 degrees? 90. 90. It makes an L. So you also have to know obtuse, acute, and right angles again. So if I were to put my little yellow piece of paper on here, these angles are not going to be 90 degrees. Because they have unparalleled lines. Yeah. Let's see. Let's keep going.
So we are going to have acute angles and obtuse angles. A parallelogram, so as you see in the name of the figure, you see the word parallel. A parallelogram has 2 pairs of parallel sides. So the top and the bottom are parallel. And
So also remember too, when it's talking about a pair, it means 2. It means 2 lines. So like this line up top is parallel to this line, okay? So that means it has 2 pairs of parallel sides. They are, they aren't. Yes, they are. They're just at an angle. That's where it gets its name, parallelogram. Yeah, they're all parallel.
the left and the right are parallel. So it has 2 pairs of parallel sides. And this one also has 2 pairs of sides of equal length. So the top and the bottom are the same length, and the left and the right are the same. And this parallelogram has 0 right angles. But again, it's going to depend on what the picture looks like. The main thing about a parallelogram is that it has to have 2 pairs of parallel sides. A rhombus also has to have 2 pairs of parallel sides. But what
Some of y'all may know rhombus as a diamond rhombus, maybe. So it has 2 pairs of parallel lines, and it looks very similar to like a parallelogram, just a little shorter. Somebody had a question, Mariah?
Yes, can I go to the restroom real quick? Okay.
It's like a little squish, but it's also got 2 pairs of parallel sides. Remember that.
What makes a rhombus special is it has to have 4 equal sides.
So that's the difference between a rhombus and a parallelogram, is that all sides are the same length on a rhombus. And a parallelogram, it looks more like a rectangle, right?
So it's like a square in that all the sides are equal. But a rhombus does not have to have any right angles. So in this picture, we have 0 right angles. The rectangle has 2 pairs of parallel sides, but it doesn't have to have all sides the same length. So in this one, the top and the bottom are the same, and the left and the right are equal. So it has 2 pairs. A rectangle has to have 4 right angles.
And right angles are how many degrees again? How many degrees are a right angle? Somebody tell me at home. How many degrees? Y'all have a chart too up here with us. Remember, if I put my paper on the corner, it's 90 degrees. You're gonna need to 90 degrees, and anything more than 90 degrees is what type of angle? Y'all have that chart up here. Anything more than 90 degrees is what type of angle?
Acute.
Nope. Acute is a baby. Obtuse.
Yes.
We're gonna have to go over that again.
So all 4 corners are right angles. And the last one is a square.
How many right angles does a square have? How many? Somebody tell me, how many right angles does a square have?
2.
How many? It has 4. If I put my little square piece of paper on there, won't all 4 of these be right angles on a square? Wherever my mouse is, I can't see it. It's got 4. One right here, right here, right.
And we know that a
If you put your little piece of paper in the corner, it's gonna measure 90 degrees. It has 4 right angles. Good job, Chloe.
square has 4 sides that are equal length. It also has to have 2 pairs of parallel sides. And it has to have 4 right angles. So you're going to be classifying some different figures and trying to figure out all the ways we can name them. So a square is also a rectangle, and it's also a rhombus, and it's also a parallelogram. So it gets to have lots of different names because it has all of those characteristics, all of those attributes. Okay, next we're going to look at some triangles and some different types of triangles. So to review, triangles are polygons with 3 sides and 3 angles. And you name a triangle by the vertices. So on this one, we would call this triangle.
We're gonna stop right there because we're not using triangles. Okay, get your journal out. That was a good little video. Get my journal out. We're gonna draw some parallelograms on there so we know tomorrow we'll do something different. Wait, before we draw, I'll go over this slide. I'll be nice and not make y'all write this second. Okay, stop sharing. Let's go over the characteristics again. Share, let's share which screen. No, I need to find it. I need to find it. Let's go over this one. Y'all can see this, correct? And cheese. Beans and cheese. Okay. My zoomers, where are you? What is that, Natalie?
It's a tiny composition book.
Can y'all see the two-dimensional figures?
Yes.
Y'all can hear too. Got 9 computers. You? Why is it not? Okay, so two-dimensional figures. Objective, I can classify quadrilaterals like what we started doing. The parallelogram, the trapezoid, the rectangle, the rhombus, the square, based on line and angles. I can identify line of symmetry like we just went over a few minutes ago with my heart. If I cut it in half and I put my hands together, they look exactly the same. For two-dimensional figures, I can identify right, acute, obtuse triangles based on measurement. You see how much you have to know this week? We already kind of know, or we kind of remember, right, acute, and obtuse triangles, or at least angles, right? But symmetry, I think, might be someone new for it coming off. Ooh, words to review, a hexagon, great. Ooh, there's a lot. Parallel. Okay. Types, there's 4 types of lines. So parallel, show me parallel lines again with your hands. Let me see parallel. Show me parallel with your hands. Everybody at home too, show me parallel lines with your hands. Right here. Show me parallel lines with your hands. What do they look like? They never touch. What? They never touch. They're never touching. Parallel, they are like the 2 L's in parallel. They never touch. They never touch. Perpendicular. Who remembers what perpendicular looks like? That's still parallel. AJ, do you remember what perpendicular looks like? They look like that. What letter do they look like? Perpendicular. Nope. They look like a T. Remember? Perpendicular. Look like this. They cross and they make what type of angles that make them perpendicular? That's not perpendicular. They have
90 degrees.
90 degrees. Whoever that was. It sounded like a dat. Who was that?
That was Elgin.
Was it?
I was
Still,
yawning.
they are a T. Perpendicular have 90-degree angles, otherwise they're not perpendicular. The corner. Huh? Yes, they're touching. This is perpendicular, but the important thing is they make 90 degrees. Intersecting would be the X. Remember, Adrian said the X. They don't make 90-degree angles. They would be the X. You have a straight line, which is just a straight line. Yeah, they do like 30 degrees or whatever. Right angle is how many degrees again? 90, and it looks like an L, or the corner of your perpendicular line. You have acute. You're acute, your baby angles, remember? Your baby angles, so they're less than 90 degrees, so like 89, 87, and I could go on till 0. Obtuse is the big, like, alligator mouth. They're big, they're more than 90, so 91, 102, 85, or not 85, sorry, 175, yeah, they'd be like obtuse angles. Yes, that would be like an obtuse angle, almost a straight angle. Then you have a straight angle, which is just a straight line. Let's see. Ooh, this is what we're gonna draw. Okay. At home, this is what we're gonna draw in our journal. So let's start. Y'all want to see mine? Mine might be easier. Hold on. Hang on. Let me find my page. Find my mouse. I've got 2 different mouses, 8 different screens. Hold on. We're gonna draw this in our journal. What was just on there? No. Okay, let's start drawing this. It's not that much to draw. Trust me. I'm gonna be nice and give y'all something tomorrow that you don't have to draw, but maybe cut out. So let's start drawing this. These are examples of parallelograms, which means they have how many sides? How many sides do a parallelogram have? 4. Yeah, they have 4 sides. Come on, let's start talking. Bless you. The pink are non-parallelograms, even though my kite and my rhombus look very similar, but don't pay attention to them. They look very similar, yes, but they're not supposed to. But they still have 4 sides, and they're not parallelograms. So we're copying this down in our journal for y'all at home. You have to draw everything, and you need to label it. Come on. Oops. I didn't make y'all do the whole. I didn't make y'all draw the ink turtle here, which would have been a lot harder. Right here? AJ, you're gonna have to come get a chair and sit right here. Come sit over here. You need to remember your glasses. I'm gonna hurt you for a day or two. On the corner right there. So you can see Bruce. Is that better? Yes. And make sure you're labeling them. And make sure it's decent, a good size. You know mine's pretty big on my page. Otherwise, you're not going to be able to understand what you wrote down. And make sure you label for you're not going to know what those things are. Make sure you're drawing this at home. Parallelograms. I wonder if it's got. Oh, there's so much. I can copy. Go to your journal. Write something. Bottom. Freeze. Freeze. We're going to add something to the bottom of that. Real simple to the bottom. Real simple. Orange, orange, purple. Orange. Blue. All these pens here. I'm gonna add something to the bottom just because I want you to do this. Oh, did you get this down? Huh? Are you okay? Now we gotta go over those symbols too. So we have to go over all that too. Symbols. Hold on. Sorry. Make sure you get to at the bottom the parallel and perpendicular lines. Just in case. Go over
And
symbols.
Anantis, can you go down? Oh, wait. Never mind.
Perpendicular and parallel. I'll try to zoom in for you. I don't know. Start.
So far.
I already did that, so I'm just waiting.
Just waiting for them.
Yep, I already did it.
Oh, when you're done. Parallel. Perpendicular.
I'm done.
Okay, make sure you got the parallel and perpendicular lines at the bottom. I added that real fast.
Okay.
Huh? Where are we talking about? Where? Right here? That's an arm. Parallel there. Straight lines and it'd be like 180 degrees. This line right here is 180 degrees. Parallel, right? What would this perpendicular, right? Come on, wakey, 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 wakey. You work so hard, you're tired. Guess I could break these. These lines would be. Just putting them down as a equal. Great. Done? Ray, wake up. Done? Wait, wake up. Wakey, wakey. Come on. Yeah, you go back to your desk. Are you all done? Yes.
I'm done.
One done. I think somebody else is done now, or somebody else is done earlier. Audrina? You're good? Ozzy, are you still ready?
I'm not done yet.
Huh? The equal sign is parallel lines. Yes. Yes. They're lines that never touch. There's one more thing I have to go over. Forgot about congruent. Forgot about congruent. What's this one on this screen right here? Congruent. I forgot to go over one thing with you.
What time is that break?
Probably like 5 minutes. I have to go over one thing at least before, two things before we go over break. know a lot of the characteristics of these shapes, or the traits, or what it has, like how many parallel sides, how many right angles. Come on, wakey, wakey. Hey, you're gonna be standing. You're gonna lose your break. We're almost to your break where you can take a nap for 15 minutes. Stay awake. Chloe, are you done or not yet? Okay. Morning's kind of going by fast. Good. All agree? Okay. All right. I forgot to go over what congruent means. What does congruent mean? I wonder if I can find a video on it. What? This? Congruent. Who knows what congruent means? Here's a video somewhere. Who knows what congruent means? What? Huh? I can't. She's writing that down, and once she's done, then I'll share my screen. Congruent. Anybody know what congruent means? No? Yes? Maybe so. Congruent means that it is similar to something else. So let me see the heading. Oh, here it is. Here's the page I need. Here's the page I need. Go PQ. PQ is congruent. All right. So. Oh, I should have put that on there. Oh man. Okay, so congruent of equal size and shape. So if I were to ask you, y'all at home, y'all can still see my picture, right?
Yes.
Okay, so congruent means of equal size and shape. Okay, stand up for a few minutes. You're gonna lose your whole break. Come on, stand up. Stand up, because you're not gonna wake up sitting down like that. Congruent, pay attention. Congruent means of same shape and size. So if I ask you which two lines are congruent on this rectangle or this rectangle, let me label it, or this square. CP. So what I would say is, where's my red? Congruent. Oh, here's my red, sorry. So if I were to ask you which two lines are congruent, well, AC is congruent to BC, because aren't they the same? Yeah. And then AB would be congruent to CD because they're the same thing, right? They're parallel. Let's look at a rectangle. If I were going to ask you, let me label my rectangle. E, F, G, H. Which two lines are congruent to each other? Meaning that they're the same size and same shape. Which two lines on the rectangle? EF would be congruent to GH, right? And then which other sides would be congruent to each other on the rectangle? FH, yeah. And then EG would be congruent to each other, right? Yeah, so congruent at home. What does congruent mean? I need to write this down. I should have need to write it down. Congruent of equal size and shape at home. What does congruent mean? Repeat after me. Of equal size and shape at home. I need to hear you.
Equal size and shapes.
Of equal size and shape. So, and sometimes you may have like two squares and they may say, are they congruent? Are they the same size and same shape? So they have to be equal size and shape to be congruent. If something's not equal size and equal shape, it is not congruent. Do y'all understand? Yes, no, maybe so. I should have made y'all write this down. I won't make y'all right now. Maybe when you get back. Okay. we're gonna have our morning break. Be back here at 10. What time are you coming back?
10.
10, sharp.
10.
See you in a few minutes.